Welcome back to the presentation of classical geometric construction of whole number angles in general. My name is Kimwe Alex from Yale University of Science and Technology. This is the first video on the classical geometric construction of whole number angles, and we are going to begin with the construction of an angle of magnitude 1 degree. We expect to get results of this kind, and looking at this figure, what you can see is a very short procedure construction. Now, before we begin, I would like to point out something here. In the previous introductory presentation, I said we are greatly going to depend on the compass equivalence theorem to help us accomplish some tasks as far as these presentations on constructions are concerned. The aspect of the compass equivalence theorem comes in because of these two chords. The general or the bottom line is to have these two chords, and that's the general agenda. We need to be able to generate these two chords, chord DG and chord DGF. If we have these two, then we can employ the compass equivalence theorem to help us generate objects of this kind, curves, arcs, and points along this curve to help us generate an angle of magnitude 1 degree. I'll be showing in this video, in the next few minutes how to generate these two chords, and with these two chords we have everything required to solve the classical geometric construction of all the whole number angles. So, as I said before, will depend on these two papers very much during the proofs and during these constructions. For instance, to start the construction, we'll go to this paper, the revised version of this article based on the angle trisection, and in this paper, there's a claim on page 10 that it is geometrically possible to construct an angle of magnitude 1 degree using the classical straightedge and compass. We will execute these 8 steps in the GeoGebra software. As stated before that, we'll be using the GeoGebra software and see if we'll be able to get the angle GAB of magnitude 1 degree. Now let me open the GeoGebra software again so that we can begin the construction. This is the GeoGebra software. I would like to raise the tools we are going to use in a construction. I need the labeling tool. From that toolbox, I need to have a line. It is. I would also like to draw some angle, to do some angle bisections. It is, and importantly, I must have the compass in place. The other tools to help us have a good view, we'll be using them, the zoom in and the zoom out tool, interchangeably. Now, before we begin, let me highlight this tool to help me move this figure slightly inside that tool. I will begin by plotting 2 points. That's my point A. I'll use this labeling tool to label the point A here. And remember, as I said in the introductory presentation, or during the introduction of the general introduction, I am not interested in these coordinates. My concern is these 2 points, the point AB. I'll then use this tool to draw or to join the 2 points using a straight line. That way I pick it and lay it between the 2 points, and there I have my straight line, which becomes the baseline. According to the procedure in this paper, short review on classical construction of whole number angles and angle trisection problem, I'm required to do some construction of this kind. I need to construct a point C that is equidistant between the 2 points A and B. That shows the distance AC should be equal to distance BC and the distance AB. To do that, I'll have to use the compass tool and have the radius AB and center B that way, and I get my first circle as that. Next, I'll start with the radius BA and the center A, and I have the other circle intersecting with the initial circle at the point I'm calling C. I'll use the labeling tool to label this point as point C. Now I get the point C. Next, I'm required to join the point B to point C and draw a curve between the 2 points, or through the 2 points, using the radius AB and center A. I already have the curve, so no need of drawing it again. Better, I'll join again the point A to point C. And looking at this figure inside here, we have triangle CAB as an equilateral triangle. Now, I'll not discuss much on it, but it's a very important feature to help us as we proceed in this construction. Next, I'll use the angle bisector or the bisection tool to help me, this is the angle bisection tool, to help me bisect this chord into two. And I'll solve that by either bisecting angle CAB and have the bisection that way. Alternatively, I would have used this tool, the perpendicular bisector, and construct a bisector of this line CB. If I start with point C, you can see the bisector moving that way, and it superimposes that initial bisection line. Now, since I already have the bisection, I delete this. I press the escape key. I'm not interested in that, and again I pick back the angle bisector tool. Now I'll have to label the point, this point of intersection between this chord and the bisection through point A, and again this point of intersection between the curve BC and the bisection through point A to this point. I label these points as point D and E respectively. Now, looking at the triangle CDE and triangle EDB, the two triangles are similar based on some properties, and one of the similar properties, side angle side. Now, if again we look at the two triangles, angle EDB and angle EDC, they are all right angled at point D. The line DE is common for both triangles. Now, in the next step of construction, I can either choose to use angle CDE or angle EDB to help me proceed and generate the two chords you saw them lying here, DG and DF. And in this case, I'll choose to work with angle DEB as is done in Alex's work. I use the angle bisector tool to help me bisect angle EDB that way. Now I'll use the labeling tool here to label this as point F. I'll go back and pick again the angle bisector tool, this is the tool, and use it to bisect this angle further, angle EDF, that I have that point G in place. Before I do the labeling, I'll do some magnification. I zoom in the figure for accurate labeling of the point of intersection between this bisection through D and the curve EF. I label this as point G. I have to label it accurately, that's why I need to zoom in. I have to zoom in. And there it is. I'll again zoom out to reduce the scale of the figure so that I can do some other operations on it. The agenda here is to construct an angle of magnitude 1 degree. And to accomplish that, now I'm going to use the compass to help me employ the transfer of these two distances. I'm going to begin with the chord DF, and with the center B, I place it there. I have made an arc to cut the curve BE at a point here. I'm going to label it as point H. I use the labeling tool, and I have here this as point H. Now, before I proceed, I'll have to change the color of this curve for good appearance. And that's how I change the color. Come here, pick that color, and it is changed. Next, again, I will use the compass tool to help me use the distance DG or the chord DG. Those are the most two important lines according to Alex's discovery from this circular plane. Now I place it at that point centered at H, and I'm interested in the bisection or the point of intersection between this curve and this chord HB. Again, before I proceed, I change the appearance of this into another color, and that's how I change it. Blue. It must have changed to blue. I'll again zoom in the figure so that I can accurately label this as point I, and then I use the labeling tool to help me label this as point I, and we are done with that construction. I zoom out for clear view. Now, according to Alex's work, if I measure angle IAB, it should be 2 degrees. Before I measure, I'll just join the point I to point A using a straight line. And I'll change the appearance of the straight line into color such as that. Let me pick this, it's a bit clearer. That one looks good. We can now use the anchor measure tool to determine the size of this anchor. Anchor I, A, to B. Here it reads the reflex anchor as 358. I'm interested in the scale between 0 to 180, and here is where I come to change it. And here it is 2 degrees. I'll now do the bisection of anchor I. I can use these points now. Anchor I, A, B, and have the bisection in place. I will zoom in the figure for good labeling, or for accurate labeling of this point where the bisector cuts the curve BI, and this is my point J. Now it's expected that anchor JAB should be 1 degree. I zoom out the figure again for good view. I'll again use the anchor measure tool and determine the value of that anchor from this scale, these points here. I'll use point J, I go to point A, then B, and the size of the anchor is 1 degree. And we are done. That's how beautiful Alex's theorem is. So simple method to help us accomplish a lot. Thank you for viewing. Please remember to subscribe for this video. In the next video, I'll be showing how to construct an angle